So we are so lucky to have had not just one, but two rock stars for our final speakers. And I have the great privilege of introducing our second. And given that Professor Lindy Elkins-Tanton is the PI of Psyche, and Lindy, I'm sure I'm not the first to say this, you're probably more in the category of the heavy metal rock star. So Psyche was selected in 2017 via Discovery. Lindy has been PI of this. I haven't had the privilege of participating in the meetings, but I do hear about them through Sarah, and I know Sarah just loves serving as your program scientist for that. Lindy is also vice president of the ASU Interplanetary Initiative. Her doctorate is from MIT. She is a two-time National Academy Kavli Frontiers of Science Fellow, 2009 Outstanding MIT Faculty Undergraduate Research Mentor, a 2020 National Academy Arthur L. Day Prize in Lectureship Award winner, and a lot of other honors and awards. I take up all of her time just listing them. I want to add too, and I shared this with Lindy via email this last week, that I heard her talk about her management philosophy with Psyche, and it was, to me, very inspiring about inclusiveness and about bridging science and engineering. And I think that we can all learn lessons from the way she does things. So Lindy's talk is on the Interplanetary Initiative. So it's an honor to have you with us, Lindy.
Thank you so much. It's lovely to be here, and both a great pleasure to follow my friend Jim, and also intimidating because I've got a totally different thing to talk about. And let me just also say, absolutely love having Sarah Noble on the Psyche project. And so we keep begging the moon not to take her away from us completely, but I know I'm talking to the wrong audience here. So nice to see so many friends here. So let me share my screen and talk to you about something that in fact is very future facing, and I'm going to be really curious to see what you all think. So here's a piece of art from our Interplanetary Initiative, and you can see what we're talking about. We're talking about how we're becoming an interplanetary species, and this is a really special challenge, and it connects to these management concepts and also to what Jim is saying about including everyone and about trying to connect to other countries as well as to groups of people. And so let me show you. This is how I think of our current space landscape. I'm imagining on the left-hand side, I've drawn a little astronaut. I'm imagining that as NASA and ESA and JAXA and SpaceX and Blue Origin and people sending people into space. It's the engineering, the hardcore engineering, the traditional kind of spacefaring activities. Then there's a vast barren landscape, and on the far right, visionary futuristic sci-fi writers. And so in 2016, our ASU president, Michael Crow, called me into his office, and it was one of those funny moments where I had appeared on my calendar, Michael Crow's office, and but no agenda, which is worrying when your president calls you in. And it turns out he wanted to talk to me about this problem. He said, look, we are becoming an interplanetary species, but all voices are not being heard. And something that we are pretty good at, or at least that we work hard at ASU, is being interdisciplinary in a really genuine way. And he said, I challenge you to bring all the disciplines to bear. So that's what we're trying to do. We're trying to create a community thinking about our interplanetary future that populates that landscape with all the different disciplines of humankind that are needed, artists and writers and philosophers and psychologists and everything you can imagine, policy and law, all the things that we need to be a complete human species as we become interplanetary. And so that is what I've made into Interplanetary Initiative. And I want to talk to you a little bit today about what it is that we're building and what we're trying to do with it. And as ever, our motto is everyone is invited all the time. And so we have plenty of public events and also things like our quarterly meetings. And when we think up new pilot projects that we seed fund, everyone is invited. So anyone who hears this talk and is interested in participating, please send along your email. We'll put you on the mailing list and you are invited. So we have a vision statement, an interplanetary future built upon cooperative and inclusive new structures, systems, and perspectives. And so you can see from this vision statement that we believe that to create this kind of interdisciplinary planetary future, we actually do need to create new structures and new perspectives and new processes. And I'll talk a little bit about what we've been experimenting with so far. We also have a mission statement. We deploy new ways of building teams and solving problems at scale. I think it has to be at scale or it's not even worth our time right now. We're in a little bit of an urgent state as humanity on our planet. Partnered across disciplines, sectors, and cultures to shape an inclusive and sustainable interplanetary future. So that's our mission. That's what we try to tie what we're working on to. And so we imagine ourselves as connecting the private sector, government, and ASU and other universities. And so we're very much outward facing at the university, and therefore an unusual structure. What we are is a pan-university initiative. We do not sit in the School of Earth and Space Exploration. In fact, I report directly to the provost and the executive vice president for research with this project. And even from our first year in 2017, we had over 50 units and centers across the university involved and 20 outside partners. And we continue to try to work that way as a networker, as a new idea bringer. And so we think about our work in terms of two different pillars. This is how our projects and communications point to our vision. The first one is empowering individuals to see themselves as interplanetary and take an active part in creating the space future they want. And I think of this like not in a kind of a, I don't know, really futuristic or kind of detached or idealistic kind of sense. I think about this in a very, very pragmatic sense, that as humanity, we are facing climate issues primarily, also obviously pandemic and many other issues that threaten everything about the things that we do, including our lovely exploration of space that we love. And one of the things we need to do is learn to look up from our dusty feet and see our place in the solar system and in the universe in order to get the perspective we need to work together and create these changes. So then our other side, our other pillar is ensuring broad societal participation and consideration in creating these structures and systems. So on the empowering individuals side, what we've mainly been working on in the last 4 years is experimental learning programs that teach agency, initiative, and problem solving. So much of standard education in our world today is still passive. It actually trains people to be passive. What we're trying to do is train people to be active thinkers, to take agency, to notice what needs to be solved, to have confidence to move towards solving it. So we've launched a new major, the technological leadership major. We just launched it during COVID last August, a year ago. I'll talk a little bit more about that. We have a very bold new project called the Open Citizen Project, and we just have pilots right now, and we are doing a big launch this fall. This is basically a structure, a process, a scaffold for training people how to identify a problem they want to solve, do the research that's necessary, synthesize that information, choose an action or an outcome, and actually execute on that action and outcome, the kind of actual path to change that is seldom taught as a process. And this is can be done in groups, in schools or outside of schools, in community centers, libraries, in companies, whoever is interested. So that's Open Citizen Project that's just launching right now. And now we have a planned online master's for scientists and engineers who are now leading large projects. And I might here be talking about myself, but I spent 10 years in business before I came back to the university and research world. And that information that I learned, never did become an expert in 10 years, but I learned a lot about leadership and management, or at least I formed a lot of opinions that have been very helpful working with Psyche. And so this is a master's for people who are doing this. So we got 50 undergraduate majors in our first year with technological leadership, and we have 5 Open Citizen Project pilots. That's where we are right now on the education side. Now on the societal side, our biggest work is internal ASU seed-funded pilots to jumpstart critical work in preparation for external funding. And I'm going to tell you how we do this because we've been developing and continue to develop and experiment with a quite unusual way to put together teams such that they are interdisciplinary from the start and move outside of the idea space of an individual person into the idea space that the whole group finds to be important. We have an interplanetary lab space, which I'll give you a little information about because it is specifically for space exploration projects that are partnered with outside partners. And then we do a lot of public-facing things. First of all, we have a special by invitation only convening about space futures, where we bring together people from government, private sector, and universities around specific problems. This fall, we will launch our Open Citizen Gathering, which is about student-centered and project-based learning experiences. And so if you have an interest in that, you might want to join us at this gathering, let me know. We have a podcast, and we do a lot of lectures and panels. So we've done 26 seed-funded pilots over 4 years. So far, they have an 8 times return on investment. So through our pilot project process, we give them a small amount of seed funds. So far, they've been able to get 8 times that amount of money in external federal and philanthropic funding that follows up. So we feel that's a good measure of success there. We've had over 25,000 people at our live and virtual events and 1 million social media impressions, and we have 10,000 monthly email subscribers. So we're trying to reach out and see who we can find. So what is learning in the information age? What is this technological leadership major that I'm talking about? I do maintain that content is now everywhere. And so content is not the thing that you go and beg the university for. It's the only place you can get that content at the university, unless of course you're coming to talk with Jim Head, in which case it is a unique source of content that's hard to find elsewhere. But in general, there's a huge amount of content out in the world, and what people need to learn is how to find it, how to decide what its quality is, and what to do with it. So we're trying to teach processes. Companies seek candidates with transferable skills and hard skills, and almost no undergraduate programs explicitly train and measure transferable skills, but we do. So our major consists of 4 parts that is designed, and it's designed to be completed in 3 years. On the far right-hand side, you'll see internships. We have 2 summer internships that are required to get people into that kind of job mindset. We have a series of foundational classes: English, calculus, programming, physics, stats, positive leadership theory, conceptualizing learning, that's cognitive science, and problem solving through strategic thinking. And then every semester, every student takes a thinking course and a making course. And these are both student-led problem solving courses. The ones that I've really been creating and working on now for 6 years are the thinking courses. This is what's called open inquiry, where the students select the goal that they're trying to go for, and then we train them in how to find, in fact, in our case, peer-reviewed research papers, whether they're freshmen or 5th-year graduate students. They all read peer-reviewed papers, synthesize their information, decide on their next questions, assess how well they're proceeding. And one of the interesting things about this is we've developed over time a rubric for scoring the excellence of someone's research questions. So we can actually help them in a quantitative way to improve the research questions that they're asking. Some of this work is also happening at our tech startup, Beagle Learning, that does a platform that allows this. So this is the major with 50 undergraduates, and where it's all an experiment. So far, so good. So then how do we speed up and target research? What am I talking about with these pilot projects? First, a tiny bit of news about the lab. It's a nice big lab, 6,000 square feet. It opened right before COVID, and it's available for users now, staffed by engineering students, very well trained, and we have support for projects. It's really a space, hardware, and software build, test, and fly lab. We've got oscilloscopes and signal generators and all the stuff we need on the electronics side, printers, this kind of thing. And then we also have a vacuum chamber, thermal chamber, drill presses, attitude test beds, things that we can use for CubeSats. And so that's one thing that we've got to play with, and that we invite you to develop projects with us for. And then this is how we've been building teams. And for these pilots, before I walk through this, I just want to say, I'm very inspired really by the way that a good mission team works. It's quite different than what we normally do in academia, although I think it's a lot more like the survey teams that you all are working on, where many different disciplines are at the table together. You know, think about a traditional university capstone engineering class. They'll say it's interdisciplinary if they have an electrical engineer working with a mechanical engineer. And in my world, that does not count as interdisciplinary. You know, for the real world, you have to have the engineers and the scientists working with graphic designers and UX UI people and marketers and schedulers and budgeters and with project managers. And you need to get all those kinds of expertise at the table. You know, maybe you need sociologists, maybe you need psychologists or economists, getting people used to really working in an interdisciplinary team and listening to one another. So we do not invite proposals for these projects. What we do is we get together, and on the far left, you can see brainstorm the biggest questions. The first time we did this, we had about 50 people in the room. We had a couple of deans, we had faculty, we had graduate students and postdocs, we had undergraduates, we had staff from all around the university, and we had people from the community, just like friends off the street, frankly, and we had people from private sector companies. So really broad set of thoughts. And the question was, what are the most important things for us to solve, for us to have a positive human space future? And we started getting some great questions up there, like how do we get the general public to support space exploration? Or how do we prepare the next generation of space explorers? And then we had more technical questions too. We get all these questions up on the board, then we vote on the most important ones. So this is a very important step. We're not coming in with the individual disciplinary leaders who say, I want to do this research question because it's the next obvious research question in my world for my subdiscipline. We want to get away from that. We don't want to be incrementalists anymore. I'll show you in a moment just the title of an essay that I wrote for Issues in Science and Technology. It just came out this week about should we say goodbye to our heroes? So I think of this as the hero model of academia, where you have one, Herr Doctor Professor who owns a pyramid of resources that include other faculty positions and staff and all kinds of lab space and money and resources, and they own the topic of their research as well. And so this creates, of course, tremendous progress, which we've had, but also a kind of a hothouse for harassment, exclusion, bullying, which cannot always be stopped by people from the outside of the pyramid, and also incremental research. Unless those heroes are visionary, they make increments of research by adding little strips of real estate to the feet of their mountain. So I think we need to get away from that. So we vote on the most important questions. We volunteer into teams right on the spot. And on the spot, people are challenged, decide on 1-year milestones. What could you achieve in 1 year to get toward this giant aspirational question you're trying to solve? Then we choose a leader, not till then. Then we send them away for 2 weeks. And if they can come back with all the missing disciplines they need for their project and a budget, then we place them under professional project management, and we give them seed money. This is how we put together these pilots. It's worked incredibly well. This year, I think we've had 4 pilots through COVID, but last year we had, I think, 8 pilots. We have about 100 team members and about 20 external partners working on this. 3 examples are the Earth Operations Center, which is a collaboration between ourselves, NASA headquarters, and MIT to create a big decision theater around climate information about planet Earth. And it's going to be both virtual and in Cambridge. We have Port of Mars, which is a project that is led by a professor of theater in collaboration with professional game designers and sociologists. And the plan here was to collect usable social science data on how people in 2 competing settlements on Mars will behave toward each other in the form of a fun multiplayer game. So we've done this. They've published a paper on it in a peer-reviewed journal with the information they got, and another one's coming. Then 5 senses in space. The idea is to bring back from space the things that a human would experience in space and load it into a holodeck so that people on Earth can have the space experience. It can be for lab work or for teamwork, or it can be just for experiencing this. And so we've got a lot of like AR, VR set up already, but a really cool aspect of this is that the teams have figured out how to reproduce smells from any organic molecules. And so one thing they've been doing is capturing the smells of moon dust and also of organic meteorites and reproducing that in the space so that they will smell what you would really smell. So those are some of our pilots. And this is the essay that I just published, Time to Say Goodbye to Our Heroes. And really what we're trying to do is create a much more egalitarian research future that moves faster toward important targeted outcomes, includes all voices, and prepares humans for our interplanetary future. And so finally, I just want to share, this is our Twitter handle and our website. Sorry, there's a typo there. I obviously didn't completely delete the Psyche website you see at the beginning, but it's interplanetary.asu.edu. And just a thought, be bold and be kind. But thank you so very much for inviting me to speak. And I hope this was an interesting kind of future looking one alternative to end on today.
Wow. Well, thank you. Thank you so much, Lindy. What a privilege to hear about this. I can't imagine a better conclusion for this conference. We're going, I mean, we saw earlier this week the Blue Origin flight, right? I mean, it's very clear we're going back to space in a big way, in a different way. And I guess where you're leading us is the right way to do it. So I will confess, all of your slides make me want to go back to school. So
that's really kind. And it's so nice to see these lovely messages, how supportive you are of each other. And now I'm receiving it a little in the chat. And so great to see so many friends. Thanks so much for this. It's really a great opportunity.
Yeah, thank you. Thank you so much, Lindy. We really appreciate it. Thanks for the perspective.